Our last big idea in this module flips clustering on its head. Instead of asking which group a point belongs to, we ask, does it belong to any group at all? This is anomaly detection, the hunt for the odd one out. Look at these transactions. Almost all of them huddle together in a normal, expected cluster. But a few sit far off on their own. Those loners are the anomalies, the points that don't look like the rest. Our goal is to flag them automatically. The simplest instinct is distance. A normal point has plenty of close neighbors. An anomaly is far from everything. So we can score each point by how far it lies from the bulk of the data, and flag the ones that are unusually distant. A close cousin is density. Normal points live in crowded neighborhoods. Anomalies sit in sparse, empty regions. Draw a boundary around the dense core, and anything stranded outside it gets flagged as unusual. But how many should we flag? We rarely know for sure, so we give the model a hint called the contamination, roughly what fraction of the data we expect to be anomalous. Say 2%. The model then draws the line so that about the 2% most unusual points fall outside it. Set it too high and you cry wolf. Too low and real problems slip through. One of the most popular methods has a clever twist, the isolation forest. It repeatedly splits the data with random cuts and asks how many cuts it takes to isolate each point all by itself. A normal point, buried in the crowd, needs many cuts. An anomaly, sitting alone, is fenced off in just a few. Easy to isolate means anomalous. Why does this matter so much? Because the rare weird point is often the important one. Fraudulent credit card charges, a failing machine part, an intruder on a network, a faulty product on the line. In all of these, we can't label every case in advance, but we can spot what doesn't fit. In scikit-learn, we create an isolation forest, tell it the expected contamination, and fit it on X. Calling predict returns +1 for a normal point and -1 for an anomaly, the odd ones out, flagged automatically. To recap, anomaly detection finds the points that don't fit the rest, by distance, by density, or by how easily they can be isolated. The contamination sets how many we flag, and methods like the isolation forest scale nicely. It powers fraud, fault, and intrusion detection everywhere. Next, we bring the whole module together in a hands-on customer segmentation lab.